Good morning and welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a link to Super Chat that runs alongside the show while it is live. And if you would like to join the debate with the page you are currently watching on mute, simply click on the link in the info box below this video to join the show and express your views on the shape of the Earth. There are, however, only a couple of rules in the Hangout. First of all, please do not swear. If you do, you will be ejected. If you are ejected, please do not try to rejoin the show using sock accounts. You will be warmly welcome back on the next stream. In a moment, I'm going to transition across to my photograph so I can share the show on Facebook, Skype and Twitter, and I would encourage anybody who is currently in the live audience to please do the same. Please share the show on social media. One more time, if you're new to the channel, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Good morning, Nichio Snows. Good morning, John Watson. And Archimedean I think I've said that right. It's morning for me, but good evening to you. Pleasure to have you here. Please share the show. Good morning, Tony Ward Deja Vu. How does this work? If you would like to join the show, David, you simply mute the page you are listening to me on now, click on the link in the info box below this video and obey the single rule of not swearing. That way you will stay and be able to debate the shape of the Earth to your heart's content. Good morning to you, Everett Anderson. Trying to be slick here, trying to share it and talk to you guys at the same time. Normally beyond the capabilities of my male brain, but we shall try. Good morning to you, Arwin. Pleasure to have you here. Please share the show. Good morning, Ron Burgundy. Why is there another hangout running? Oh, didn't realise that there was. I don't think there is. I think there's just one. Do a search on Flat Earth Live just to make absolutely sure. I only see the one, my friend. Cartoon Head, good to have you here. Just finish off sending this link to a few more people and then I will do my link again and go on mute. One of you from the live audience, hello to you, Charlotte, could just click on the link and check it works. I'd be very grateful. Good morning to Fire Don TV Fireman Sam. Excellent screen name. Very pleased to have you here. I'm pretty much done. I've just shared the show on Facebook, Skype and Twitter. I'll run through my links again and you may hear them a third time should we not be joined by any guests. Arwen's here. I will run through my links. I've started, so I'll finish. If you are new to the channel, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live. And if you would like to join the show, as Arwen has just done, simply click on the link in the info box below this video to express your views on the shape of the Earth. There are only a couple of rules. Number one, please do not swear. If you do, you will be ejected, but you will be warmly welcomed back on the next show. So please do not try to rejoin using sock accounts. Go and take a walk, take a cold shower, do whatever you need to do to calm down, but you will be warmly welcomed back next time. So if you've not done so already, please share the show on Skype, Facebook, Twitter and all those other social media platforms. And with that, I'll say a quick hello to Arwen. How you doing, Arwen?
Hey, yeah, I'm doing good, Nathan.
Excellent.
I thought I'd just pop in for a moment because usually when I do, it doesn't take long for Globers to then be drawn in, as it were, to compete. So I thought I'd help you out there.
That'd be awesome. Tell us about the shape of the Earth, Arwen.
Well, it's not a globe. Pretty sure about that. And, well, technically, if it were, then nobody seems to know with any precise certainty what the exact size of this globe would be. So, because, yeah, there's theories about it, but the measurements don't add up. And then we get back to the conversation we had yesterday about perspective. And there seems to be a apparent curve visible, which are, in my opinion, mostly optics, which suggests some kind of curve. But whatever's measured, whatever's seen, whatever's observed does not match up with a consistent curvature, which would be absolutely essential for an exact shape like a ball. So yeah, that's just not it. And concerning flat Earth, I guess to be able to deal with these types of hangouts, I'll just take a step back and just say, okay, sure, I don't know. Let's just keep the talks going. And I can get into arguments from both sides. So yeah, I guess that's what it's about the debate, and keep it going. Get misunderstandings out of the way, and try to learn how to deal with each other's objections and egos and such, which are very present among many of us, as we've all discovered by now. So,
yeah, it's interesting watching you disagree with Anthony Riley about the magnetic fields of Earth, because he's on your side.
I think that really was a misunderstanding because of the shape of this map representation with the circles and everything. It kind of looked like wood rings a bit, you know how a cross section of a piece of wood, you get to see these rings and everything. Well, it kind of looked like that, and just the shape suggested that it would be a literal magnetic field shape, which, yeah, well, if there is like a central magnet there causing a magnetic field like that, then you would automatically assume that there is magnetic direction also related in this map, but it wasn't. It was just a energy intensity map, and people didn't seem to get that, some of them. So yeah, that went on for a long time, that part. But yeah, I haven't seen any maps or projections or anything that actually show like, hey, look, here's the magnetic direction. No, it's just I guess a given from higher ups that all magnetics, it all points north. It always does. And that's such a given from the higher ups that there's not even maps that would represent that there may be slight variations with the magnetic directions on our known realm. So
there is one, at least one, only because somebody shared it with me literally a day or two ago. I'm not going to mention who, and I'm not going to show the map because it may be something that they didn't want me to share, but I've got a top-down magnetic declination map of what you would call the flat Earth. So yes,
Wow.
there is definitely
Okay,
a map
I
like
would
that in existence.
definitely like to see that. Is it based on theoretics, or was this all based on land measurements, like
Absolutely no
getting
idea.
out the
Like I say,
compass
the person who shared
in
it with me
relation
just,
to the direction of the
I
sun?
don't know, Arwin.
Because
You're about to
that's
ask a question I don't know the
it's
answer
very
to.
confusing.
I don't know. So the person just literally just shared me a static map and said, "Here's a map of the declination lines." That was the only explanation I have, and I went,
okay.
"Far out. That's very cool." But that's
Well,
it.
I
That's the
guess
only
it's cool,
information I've
but
got.
it's figuring out the magnetics of this world and the actual how the lands and the continents are positioned in relation to each other and the rest of the world is going to be very complex, because it's now all unified. Like all the maps and everything that are built are all unified around the concept that it's all based on the magnetic direction. Basically, that's how it's all designed, and it's all based on the assumption that all the magnetic directions are just one direction, north, and that's it. But there are possible variation in the magnetic direction on the Earth, which makes it completely intangible almost. It makes it a lot more confusing. So the only way to actually figure this out is by combining everything. Like you go to each location on the Earth, you measure what's the magnetic direction, then you measure what is the sun direction, like when is the high noon, and what, see, you have to compare the magnetics with the actual heavenly bodies and how they are directed, and then you can get closer to actually figuring out how the land is positioned really in comparison to the rest of the world. It's much more complex than it looks at first hand, because we're also used to all mapping, all that type of stuff is always based upon the magnetic direction is one direction, and that's north. That's how everything is designed for us, all the mapping that we know, basically. It's a very hard obstacle to overcome. Do you understand what I mean, Nathan?
If you've got your Skype open, you can go and have a look if you like. We've just been joined by Curved Water, so that'll give you a couple of minutes. But go and open your Skype. I've just sent you that map. How you doing, Curved Water? Very pleased to have you here.
In Skype, okay. I'll take a look. Thanks.
Can you hear me? Earth calling Curved Water. Come in, Curved Water. Hang on. Okay, no problem. Yeah, I'll do a link. Why not? Arwin's away looking at Skype.
Yeah, I don't see that link of yours, by the way.
Really?
Nope.
Yeah, Arwin, Skype. It doesn't say you're online.
Yeah, I am now.
Oh no, you're on a new account. Okay, no problem. You've
Yeah,
just said
the
hello
other
to
one
me.
is completely compromised.
Yeah, no problem, no problem. There you go. Send.
Ah, thank you.
No problem. I'll give you a couple of minutes to look at that. I'll do a couple of links, then hopefully Curved will be ready. So I'll just turn you guys down for just a second. You can probably hear my kid tapping away in the background. My apologies. Eleanor, can you let Daddy do his links? If you are new... No, clearly not. If you are new to this channel, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a link in the info box below this video. And if you would like to join the debate, as Arwin and Curved Water have already done, feel free to click on the link in the info box below this video. Be sure to mute the page you are currently watching before you do that. With that, there's only a couple of rules to mention in the Hangout. Number one, please do not swear. If you do, you will be ejected. However, you will be warmly welcome back on the next show, so please do not try to rejoin the show using sock accounts. If you've not done so already, please share the show on social media. And hopefully that's given Arwin just enough time to have a look at that map.
Yeah, it looks interesting. It's a bit rough, but yeah, it looks very interesting. I'd have to figure it out, basically.
Sure, like I say, once I get some more information
It's too bad that there's no sources. It kind of looks like it's a cutout of some kind of encyclopedia picture. Even like the the typical printing quality and everything. It looks very encyclopedian. I wonder what it's taken from. This is definitely not a typical modern computer-generated image, in my opinion. I think it's like a scan of something.
Could be. Like I say, I don't have any further info on it, but it was certainly interesting when I saw it. I thought it was very cool.
Yeah, it is.
Oh, Curve Water's already dropped. So.
Yeah, he had to reboot.
Oh, right. I'm sure he'll be back momentarily.
Mm-hmm. Yeah. So,
you feel free to carry on.
I listened to the debate hangout yesterday afterwards, and my microphone seemed to be a bit, how do you say, grindy, a bit staticky.
Yeah, the reason for that is everyone, when they're over enthusiastic, the worst culprit for this was Truth Seeker. So his mic sounds perfect. He comes on, I level him up, he sounds great. But as soon as he starts to get enthusiastic, he gets right on top of his microphone. He gets closer. And the problem is that either the software or his mic is compressing the sound. So it goes from really loud, because he's on top of his mic, and the mic or the computer goes, ah! And compresses it down to virtually nothing. At which point, he's half the volume of everyone else on the panel. So all someone's got to do is just say, I don't agree. And the next thing you know, he can't be heard at all. He's completely cut off.
Yeah, I noticed that a lot. Indeed.
But he was like, oh, no surprise that I keep getting cut off. It's like, no, just try to be a bit less enthusiastic. Because at the same time that was happening, you were very calm, Arwin, and you were a good distance from your mic. You were speaking very quietly, but you could cut him off just with one word, you know. But you weren't speaking loudly.
When I went in, and I'm gonna try to keep doing that. I just went in like, okay, I'm not gonna get agitated for being interrupted, because it's bound to happen a lot. So I'll just take whatever room to say things that I got and just keep it like that.
Take your chances.
I think we've been joined by...
I was going to say, yeah, I'll do that. Thanks, Arwin. It's okay, I'll do the introductions. We've been joined by Physics Warrior and Curve Water. How are you doing, first and foremost, Physics Warrior?
Good morning, good morning, good morning.
Good morning to you too, and hopefully we've got Curved as well. We shall see.
Good morning. Is it working this time?
Does you're just a bit quiet? I'll turn you up. Yes, you're coming through nice and clear. Good stuff. Right, I can finally go on mute and play with my kid. I'll leave you guys to it.
All right, where were we?
Welcome back.
Well, Arlen, I heard you talking about magnetics and declination and maps, and you seem to be under the impression that we don't really have much of a clue what's going on there with regard to direction and things like that.
The magnetic direction, yes. I think that in all the designs for maps that we've used and that humanity has used in the past centuries for exploration and everything, they figured out like the magnetics are inconsistent probably in some way in the direction compared to how the heavens set and all those things, that they just decide, okay, let's just uniformize everything. Let's just pretend like the magnetics always go north, and we then build the maps. We design how the continents are laid out according to that principle. It may not be accurate, but it'll at least be understandable and usable. And hey, maps are there not to be a precise representation, but to be used to explore, to be convenient. So that would make a sense in a practical way.
Okay, well, what about the fact that that's not how it works? Are you not aware of magnetic declination maps? Do you know what a magnetic declination map is?
No, not in this case.
All right, well, good. Fair enough.
The map I just sent you is a magnetic declination map, Arwin.
Oh, that thing, right.
It's including the sphere. You're getting the curve.
Okay. Yeah. You can drag that in all you like.
Not really a curve.
But in this case, I'm going to treat subject per subject. So this is magnetics. I basically, at this point, don't care at all. If it's a globe or if it's flat or whatever it is, I just want to know the details about how magnetics function, because I believe that the layout of how the continents are divided are inaccurate because of corrections made to make things more tenable in accordance with the magnetics on the Earth. I think that this magnetic declination map looks interesting, but I don't know. It doesn't look like it's actually it's actually giving us help figuring out the literal magnetic direction on Earth. It's again based on fields a lot. It's not. If I look at this map that Nathan shared with me, then the magnetic direction should be all over the place if it is actually a representation of the magnetic directions. So again, my point, it's not linear and consistently all pointing in one direction.
Correct.
Which means that it's going to be a mess.
It is. And it's mapped out. And people can use their magnetic declination maps to correct for the magnetic declination where they are. And when they're traveling, you use the magnetic declination map to determine how far east or west of the magnetic field line true north actually is. There are online calculators.
I don't think that is really how people explore.
No.
They do actually traditionally use the star heavens to explore very accurately, including
I'm talking about using a compass.
Well, the compass is just an assist. It's just an orientation assist. The actual measurements, the cornerstone of the decision making for exploration is actually done in accordance to the heavens, the North Pole star, which is the most stable, accurate, invariable in the whole thing. So magnetics is just a side effect. It's just like, oh yeah, what do the magnetics say? Does it line up with this map? But it's not really, it's like a checkpoint. It's not what the entire exploration path is based upon, really.
Why are you trying to use it? Why are you trying to use it as a way to say that we don't know where we are, what we're doing, which way we're looking?
No, I'm just saying that what you said, that like people use the magnetic declination lines and everything to explore, it's not true. It's not the main function. It's not it's just a side thing. They added it as an extra checklist, as it were, for exploration. But the exploration has traditionally, for a long, long time, been purely based on the charts of the heavens, basically.
Arvin, if you're not taking if you're not using the declination map that's published out there and people are using it, how are you researching it? What kind of map or what kind of evidence are you getting to use to formulate your map or your perspective?
What are you talking about?
What evidence and what proof are you using? If you're not using a map, how are you getting the information that you need to map out where you want to map out your location, the area, the magnetic north? How are you getting that information?
Well, if I would go out and determine this, then I would definitely check out where the sun goes up, when it goes down in different times. I would also check the compass for what is north, and then I would see how these results correlate, and then try to figure out what the most logical conclusion is. I wouldn't just take out my compass. Oh, that compass says north is there, so that is the absolute north. No, because I know now that that's not what it's like, really.
All right, so based on your evidence, you were able to compare against the declination map? Or have you seen the declination map?
I just now, as in a few minutes ago, for the first time ever, saw the magnetic declination map, if that is really what it is, because Nathan sent it to me over Skype. So
Okay. So, I mean, yeah, I would definitely want to look at that and see if it's provable, because I didn't know there was a magnetic declination map.
well, the biggest variables on this map, as far as I can see, seem to be mostly in the absolute most northern region. So, say, like mid-north Canada, Greenland, uh, and the northern parts of Russia. They would be the most uh, interesting to actually check out how the magnetics work there, because that looks really weird. But the rest of the world,
Can you display it?
of the
Can you
known,
put
it
up,
doesn't
Arwen?
seem too bizarre how it's
Can you
laid
share
out.
it?
Oh.
Can you
So,
get it up on your
but
screen,
it's
Arwen?
definitely worth checking in person, as it were. Like, how do the magnetics really line up? Basically, we should have like 100,000 people walking all over the world with a compass, and then just check, like, okay, where's it pointing, and then
Okay, we
note
do.
that on the map. Like, is it really whatever the military that probably did this magnetic thing? Are they really accurate? We should
Arwen,
probably all do it ourselves to be absolutely sure.
Oh, that's what we're doing.
multiple
Are
sources
we?
for these. This is all. I mean, this isn't even arguable, Arwen. You may not understand it yet, but this is not up for debate. This is not in dispute.
What are you talking about?
I don't know that I can explain it to you. You've got the
Well, if you
map.
can't even explain to me, then how can you be so
No, to you.
undeniably
I can
certain that
I can
whatever you're
explain to
talking
the
about now
audience,
is
Arwen.
absolutely right?
I can explain to the audience, Arwen, not necessarily to you, because you have your own views here based upon your. You just found out about a magnetic declination map, and you have all the answers. You know how
No,
things
I
work or
just
what
know
needs
how
to
to
be done.
proceed.
No, Arwen, this is a done deal. People
No, it's a
use
done deal
compasses.
by other people, by
Yeah.
people that we
By
have
the
proven that we
Arwen,
cannot trust.
Arwen, this is a done deal by the world, man.
Yeah, sure. Well, that you may trust in the
This is
entire
new.
world for you to do the
Okay,
deals for you. I
then you
don't.
go check it. But to your example, we should have hundreds of thousands of people out walking around with compasses. Dude, we do. People use compasses. People use his declination. They use the deviation of magnetic north from true north to figure out their bearing and heading and everything, where they actually are.
Whatever you say, man.
Dude, this is Boy Scout stuff,
Yeah, well, I didn't
military,
join the Boy Scout
everything.
stuff. So
This is in use. This is in use. This is not a secret. It's not a mystery to anyone except maybe you.
yeah, well, things being in use doesn't actually mean that people absolutely understand what they're using. Just means that they use it, they found a method to use it, and that it works. That's all it
No.
means.
Yes, it does work.
Yeah,
And
that
you're
doesn't mean that
questioning-
they actually understand what they're doing.
Okay, this is a pointless little bickering right now. So I'm out of this little thing. Most people
Bye.
know what's going on with this, Arwen. And seriously, good luck to you catching up. I really hope you do.
Bye.
It'll take some time. Look into it. Think about what this means, how it's used.
You don't have to talk down like me, like you're my teacher, okay?
But I
I
can.
don't need that.
But I can, because I am.
I know
teaching
you can, but I
And
don't
I'm not
need
talking
that.
down
You're
to
not
you.
helping me. You're not helping anyone. You're just.
I'm not talking down to you,
Yeah,
Arwen.
you are.
No,
Yes, you are.
you're a little too sensitive. Come on now.
No, I perceive modes of behavior. I perceive the wording you use, the tone you use. You're talking down to me. I don't need that. Okay.
I just got a ticket from the tone police, Cat.
Wow. Arwen, you still there?
Yeah.
But are you going to give the chance to at least look at the map and see if it's observable and it works with your map? It could be an actual leap forward or a little bit more faster towards your research. So I mean, there are other things out there you can pick up as tools. But if you pick it up and it doesn't work, and yeah, then you can debate it. But for right now, that declination map does exist, and it's out there right now, and you know people are actually using that map.
Okay, sure.
Who knows? You may have come something else. You may come up with something else different. So we don't know. But for right now, Curve just put something out there. So if you
As
want to
far as
debunk
I
it,
know, all maps are used and designed to be, or let me start again. All maps that have been made for us, for people to use as exploration, are meant for exactly that, exploration. It doesn't mean it has to be accurate, as long as it can be used and it will not run people into a corner, it will not make people lost, then it's functional. And it doesn't even need to be literally correct, as long as it works. That's how maps are designed for us. It's how during the exploration age, the maps were designed for us with clearly out of proportion continents and everything. It was
sure, yeah,
designed for use, not to be accurate.
yeah,
That's
we
what
know
it's
that.
designed for. That's what maps are designed for.
I think we're like what the third or fourth map now. From Mercator to Peterson, from Peterson to Gleason. Yeah,
Yeah,
they're
but just see what I'm saying here. Maps are made for use, and as long as it works, it's useful. That's
Sorry.
all they care about, really.
Okay, Arwen,
They're
sorry
not
to
meant
interrupt
to
you.
be
We've been
accurate
joined by a new
representation.
guest. Can I just say a quick hello to Green Juice? Can I say hello, Green?
what's going on, Green Juice?
Oh, yes.
Oh, maybe not. Sorry to interrupt. As you were.
No problem. So, yeah, about the magnetic declination. Hey, as it looks, I guess it's quite usable. People can use it, what they get to see on this map right now, and that's fine. But does it work exactly the same if they take a boat, for example, and go north beyond Russia, go north beyond Greenland? Does it still match up there? I don't think a lot of people know this, really. They never get to check it. They only get to check it on the lands and the regions on the sea that they're allowed to go. So, as long as it functions exactly as the map says in the regions that we're allowed to go, then it works. Doesn't mean that it is universally correct, because we can't check it, because we can't go in the regions that we're not allowed to go to check if it's correct. See my point?
Wow.
I see your point. Yeah.
Exactly.
Oh,
Sure,
I'll pop you on mute, Physics.
I'm charging my phone right.
We will be joined hopefully by Madman in a moment. So yeah, when he does, if you can just literally give me a 30-second gap in the conversation just to say hello to him, I'd be very grateful.
So, Arwen, are you creating a map?
Creating a map?
Are you making a map, or
No,
or just okay?
not really. I'm like, mapping is such a detailed process. It takes up a lot of work, and you really have to be good at it. I'm more of a theorist. I just do conceptual puzzling. Like,
Okay.
when would a setup be sustainable or possible, or what would the final result inevitably be? That is what I do, and that's how I try to fit all the models in their own way. I figure out the globe, I figure out the enclosed circle-centric map, and the rectangular looping concept. That's pretty much come from me and a few others. Just see what would make it logical. That's what I'm interested in. So I'm very much a
Hello.
I'm here. You're still here.
Okay. I thought Thanks, Kurt.
Here, you're still here.
Okay.
We've been joined by
Yeah,
Green Juice again. If I can just say a quick hello.
Hey, no, I was just trying to say.
Green Juice again. If I can just say a quick hello.
Yeah, I'm actually Madman.
Hey, no, I was just trying to say.
You've got your watch page mute on.
I'm actually.
Yeah, I'm Madman.
Sorry, my internet connection.
I'm just acting weird. It's not letting me put my real name on.
Don't worry about it. You're good. We can hear you. That's all that matters. Good to have you here anyway. Thank you for being here.
I have a different name like every month anyway, so you know it's all good.
Okay, my internet connection went bad. I don't know where I dropped off.
Probably magnetic
Well,
field interference.
Yeah, I think you guys are talking about exactly what Curve just said. The magnetic interference actually kind of proves why or why not the Earth is a globe, something like that.
No.
Wasn't totally.
No, I don't. I think we're purely into the magnetics and just the map surface to figure out what is correct. I think that was the main focus, not the conclusion we should draw if it's a globe or flat or anything. Just the measurements.
Yeah. We're talking about like how to navigate during the day when you don't see stars. Just, you know, how would you find north, or how would you find 280 degrees west? Things like that.
It would actually be really hard to do that, right? On a flat Earth, because
No, just a flat map.
Yeah, or regardless, right? Because you know, due south on a flat map is always going to point away from north, right? And well, you know, then again, that's almost just as hard as on a globe map. So let me take that back. Now that I've
Basically, for exploration purposes, the star locations are the best to figure out the exact position. That's why seafarers use that mostly. But
yeah, but I think we're
the
talking about
sun
during the day.
position during the daytime is also a useful indicator, but it actually requires for you to stay at an exact spot for some time to see the sun coming up, going down. Then you can basically point, okay, where did it come from? Where did it go down? What is the time during the day when it's at its top? And then with that information, like a triangulation thing, sort of, you can basically figure out what is on your location, the exact north and south.
Well, how do you use sunrise to figure out what direction it is?
Well, you figure out the spot where the sun comes up and goes down. You see where the sun is at its top during the day, and then you draw basically lines.
All right. What about just specifically sunrise? What about sunrise tells you what direction the sun?
Well,
like
the sun always rises in the east, everywhere.
The same azimuth
But
every
it's
day?
roughly the east. It's never really exactly the east because that varies on the how north you are on the Earth and how south, and even
Is that the
season.
case?
So, but it
Are you
does
sure about
always
that,
rise in the
Oakley?
east.
Are you sure about that?
Yes.
It's based upon where you are on the Earth? I would challenge you.
It never flips. It's always the east. It's just how much east is it really?
No. Okay. Arwen, here. I would recommend to anybody interested in this, pick 3 locations on the Earth. Something like 30, 45 degrees north, something on the equator, and 30 to 45 degrees south. And on the same day, check the azimuth to sunrise, and do it on the summer solstice, do it on the equinox, and do it on the winter solstice.
Yeah.
And you'll see that the azimuth.
How would that be different, though? How would that be different on a flat?
Well, hold on. Let Kurt finish. Let Kurt finish. He's not even done.
Thank
yet.
you.
Hold on.
Thank you. you'll notice that the azimuth to sunrise is most, with the exception of a little variation of a few degrees, couple degrees, at most, on your position. The sunrise is well north of east for all three observers, from the mid latitudes north, from the equator, from the mid latitude south. The sun will rise north of east for all three of those people on the same day when the sun is up, say at the summer solstice.
Yes.
Now, on the winter solstice, it's going to rise well south of east for all three observers on the winter solstice.
Yes, I know that.
Now, this is in direct contradiction to your claim.
No, it's not.
That it depends on where you are on Earth. No, it's where the sun is above the Earth.
No, it has nothing to do with that.
It actually does.
No, it does, because you just said exactly what I said. It always rises in the east. There may be a slight variance if it's slightly north or south of the exact east, but it always rises in the east.
Of 27 to 30 degrees north.
Yeah, it's still east. It's not west.
What?
It still rises in the east.
Okay, in a general sense, but I'm telling you.
That's why I'm saying you have to
on the summer solstice, the sun's going to be rising about like 27, 30 degrees ish, depending on where you are. It does vary a little bit, but the sun's going to rise well, like I said, 27-ish degrees.
Yeah. Okay. But do you agree that no matter the season or anything,
not a couple degrees,
no matter the season or anything about where it exactly will rise and set, that the sun always sets at exactly the same angle compared to the west as it would rise compared to the east?
Yeah, within fractions of a degree.
So then my point is exactly the same. You can draw a line from sunrise to sunset and then use that as an orientation tool to determine the heavenly body related north and south without using magnetics.
Arwen, I know, but you did say that.
But that was the entire starting point.
No, it wasn't.
Yes, it was. That's how we came into this discussion.
I'll tell you what. Okay, well, after the show, I can go back and listen to what you said, and next time we talk, I'll bring it up. Okay.
Fine.
I'm not going to sit here and bicker with you about it. But if anybody out there would look it up, just look it up on time and date. Pick those three positions I talked about and check it on solstice, equator, and the other solstice.
Yeah, it's good. I don't have to. You're specific. It's right. It's gonna from the summer solstice and the winter solstice. The sun is definitely gonna move in a different direction. It's actually gonna come towards you in a different direction.
But the angle doesn't change. It just the circle.
What angle?
Slightly more north or south.
Can you specify
that? But it doesn't change its angle at all.
Arwen, what angle does it change? Can you specify that, please?
No, it doesn't change any angle. It basically how the ring over which the sun moves either more north or south.
No.
Yes, it does.
Yes,
it does.
Oh my God.
The path that the sun takes, depending on the time of year, as a globe around us, migrates south or north. During the summer, the circle goes more of the sun path goes more south. You get more sun because of this. And during the winter, it goes the other direction. So you get to see less sun. That's exactly how it works. And it's always in an exact angle towards the north. It's always... It never the sun goes up slightly north of the east and then sets slightly west, slightly south on the west side. It never works like that. It always sets the exact same variation of west and east. Always. If it comes up slightly south of the east, then it'll go down slightly south of the west. It's never any other way.
Well, not slightly. It can be up to 27 or more degrees.
Fine. I'm trying to make a point here.
And I am too.
That's good.
Is that okay?
yeah, sure. Don't see how it's really relevant. How many degrees it is.
Because you're using terminology that appears to be trying to minimize the effect, and I'm not sure
No,
why.
I'm not trying
but-
that at all. The only point I'm trying to make is that however the heavenly bodies and the sun, however its direction, like how the path of the sun is directed, it's always in relation to the north, and it never changes its angle.
All right, we're not. What do you mean in relation to the north? How about in relation to the south?
The same.
You keep saying it
It
never.
just doesn't rotate.
You have to be talking about a different angle than I am, so we're probably not going to
Sun
communicate
always
on that point.
comes up
I'm talking about the angle of
exactly
view
as
as an
south from the east as it goes down south from the west,
okay, all right.
and exactly the other way around too.
Hey.
It comes up north of the east, then it will go down exactly as north from the west. It always is like this. It's never turned.
All right, you might have a point there if I understand what you're saying, the way you're saying it, but
It's very hard to explain. Yeah,
just that
you'd
one
have
point,
to
yeah,
get
we
into
agree on that.
holographics for that.
This
It's just
this is kinda
observable.
silly.
I watched
Really silly.
Paula did like Bad Christian. Paula did a lot of really great hangouts about it with very good pictures that are much
course.
better to explain this than I can with
Very
just
good.
words.
Okay, let's move on then. Why don't we talk about something else?
Sure.
Nobody seems to be enjoying this anyway.
Well,
What about you,
apparently-
Sai? You got anything you'd like to talk about? Grain? Anyone?
He's muted. Yeah.
Oh yeah, I'm actually mad, man. No,
Why
dude,
you
not
mad,
really.
bro? Why you mad, bro?
No, I don't know, dude. So today, I guess I spent a lot of time today, right? I was playing poker and I was watching just a train just driving. Like there was a live stream of a train just driving, and in Norway, it was freaking beautiful. It was so peaceful. Just having that on the screen instead of having like all this like flat earth like talk and like arguing and crap like that, right? Just having a train just drive through the snow, through the trees. You can see the mountains in the background. It's beautiful, right? Anyways, I just thought I'll share that. It's got absolutely
Thanks.
nothing to do with anything.
Thanks for sharing.
Right? You asked what's up. That's what's up.
Well, there we go.
So what's up with you, Curved?
Ballin'.
What do you want to talk about?
Whatever they want to.
I
just
mean,
want-
like
I just
usually
try to
you're
keep it
very
straight.
you're a very responsive type of conversationalist. But I've never like okay, if you had to pick up a point to talk about, what would you want to talk about?
Well, we could talk about the symmetry involved in what we were just discussing with sunrise and sunset and where the sun is above the earth and how that works. Makes perfect sense on a globe. Doesn't really make any sense on a flat earth. That could be something.
It makes sense on anything because it's all holographic. It works either way.
Well, there you go. It's all holographic, folks.
No,
Nothing needs to
it's
make
not
sense.
all holographic. The heavens are holographic.
Well, you just said it's all holographic. I
Yeah, the
repeated
heavenly
you,
bodies are
and
holographic.
I repeated you, and you corrected me. So okay.
So, Curve, would you say that you'd ask that because you want to be proved wrong, or is that just something that
Oh, I
you
can't
absolutely-
be. I can't be proven wrong.
No, sure you can.
Give it a shot, Arwen.
No, if you're gonna start out with that kind of statement, then you're like putting it out there that you're not open for a reason because you've set your
Oh, it's a
you've set
challenge.
your senses
Oh,
on
wait.
what you are right.
Arwen, it
Not a
doesn't
good
matter if
invitation
you
for
think
it.
I'm open or not. The challenge is there. Are you
You're
up for
open
it?
for discussion, but you know you're right. Well, that's not being open.
Oh, I do. But see,
No,
here's
it's
the
not.
thing. If you can prove me wrong, I will change my mind, Arwen.
I doubt I can, because you wouldn't accept anything.
Well, you
Just
got to believe in
resort back
yourself,
to your
Arwen.
teachings.
Believe in yourself.
I believe in myself,
Come on.
but I also believe that people that have that kind of mindset are not open for
Well,
new
demonstrate your point that it works on either, and that it doesn't. It's not a point for the globe.
Well, nothing that we see in the heavens, the star globe around us, the paths of the sun and moon, the stars, none of it proves anything correlating to the physical shape of the earth at all.
How do you rely upon the position of the sun to try to figure out where you are?
Centered around each observer.
Why do
And
you
they
trust
have
the
no
position of the
literal
sun to help
correlation
you
with
determine
anything
where you
physical.
are, Arwen?
Well, thanks for actually letting me explain as I'm trying to say
I'm
something.
asking you a very
It's very
salient
helpful.
question.
Very open.
See, on the one hand, you're using the sun for direction and all that, and then on the other hand, you're saying you can't go by anything that you see.
You can. You're twisting my words again, dude.
No,
I
I'm
said you can
paraphrasing it
determine north
accurately.
and south
Quite
using
accurately.
the position of the sun. I said just now you can't determine the shape of the earth.
Well,
Hey guys,
if
I'm
you
The
kind of
heavenly bodies. I didn't
If
say
you
you
don't know
couldn't
how.
determine north or south with it. So don't twist my
I'm
words.
kind of led curved into this conversation. But Erwin, I've never met you, man. Nice to meet you, bro.
Thanks.
Yep. I think Cat Earth just joined.
I'm going to say,
Yeah.
Cat Earth's just joined us. Can you say a quick hello, Cat Earth? Very pleased to have you here.
Hello.
Good to
Hey,
see
Cat.
you. Thanks for being here.
Thank you. Remember to share the show, guys. I shared it. I've never shared a show, but I shared this show. So you should share the show too. Flat power.
Thank you very
thumbs
much.
up.
And donate super chat. Super cat.
Yeah, Super Chat's been lagging this morning. Fanny Lance, are you out there? Get the ball rolling.
No, Fanny? Oh, well. Oh, I'd like to make a point, Owen. You're saying about the heavens all being holographic and all this. What difference does it make if they're holographic to the point being made? Like
It
just
makes
because
all the difference.
So you're saying that they're actually not even so much holographic. They're like local projections from our brains to
No.
trick us into thinking that the Earth's a globe.
No, they're not local projections from our brain, but I'm saying how they manifest visually is in relation to each
where we're
observer, including
Yeah.
cameras.
That's
Whatever
basically what I'm
watches
saying.
will determine how they are
Yeah.
projected.
Yeah, and what evidence do you have of that? Because that's fair enough to make the point.
Non-triangulatability.
It's a good point you're making because at least you understand the problem.
Mm-hmm.
So that's why you're thinking of this. But then you can't get angry at us for not accepting it when you haven't really got any evidence. It's a good theory.
I do have evidence.
Okay.
Well,
I
I gotta
had evidence for over a year. I've been
Okay.
talking about this in my Hangouts. I can't help that people just ignore it.
to Erwin's
think-
defense, the technology is
I talked about it yesterday, this evidence.
The technology-
Non-triangulatability.
Like
None
if you
of
look
the
at
heavenly
technology-
bodies are
Hold on.
triangulatable to be in an exact, literal location. It's all apparent location in relation to
no,
each
no,
other,
no,
and
no,
they
no.
never line
what
up
is-
in
what is
any
with this
way.
guy?
Why do you think it's designed to make us think it's a globe then? If you understand that problem and you're thinking of it on those lines,
Well, I
what's
can
what's
only
behind
give
that?
my
Make the point.
philosophical
What is he
answer
talking
to
about?
that in
It
the
can't
book.
be
Let
triangulated.
him answer because I'm interested. He gets it. He gets that there is a problem with what we're seeing above us and it can't be flat. So he's making this argument, which is fair enough.
He
But
doesn't
what
get
makes
that.
well, maybe I don't know. But why?
You
what
want,
makes
you want a
think-
real answer?
Yeah,
I'm not sure that anyone can really handle the answer.
just give it to us. I
Okay,
think they-
well, the heavens were designed to fool us,
yeah,
as are most elements in this earthly realm, and it's a necessity because the more you really understand about the nature of this world, the nature of our spirits, and the purpose, the beginning and the end, the harder it becomes. So almost everything in this world is designed to keep us ignorant and keep us dwelling, because it'll make our existence more tolerable. That's why.
There you
So,
go.
Owen, when you say the technology is okay, when you say that projections are, if you want directed to the observer, are you thinking about the same kind of technology where, like, 3D TVs today? How we used to always have to wear glasses, and now you have these TVs. They haven't actually been released in mass amounts, but you can essentially get a TV where, as long as you're sitting in certain areas of your living room, you'll get
dual lights. It's trickery. It's very smart.
Right.
It's
So
a very different thing, though, isn't it?
It's different, but it's also directing lights.
If you want to know my opinion
right?
on what makes the heavens holographic, how that would roughly work, then you'd have to get into literal smoke and mirrors.
Yeah, well, I get what you're
Because
saying.
that is
Right?
how the holographic nature of the heavens are. It's all reflection based. It's very complicated. It's integral to the entire design of the physical world as well.
So really, what you're saying is, and I'm not mocking you for this. I'm just trying to get where you're coming from. Your whole thing of flat Earth really comes down to a sort of spiritual belief kind of thing, because you believe the heavens are tricking us. So in that case, it's very hard for us to prove that, right? If it's to do with gods or whatever, or God or something. You literally say
design.
Yeah.
I'm not talking about gods or anything. I'm an absolute firm. How do you say? I believe the world is designed. I think life was designed, and I'm pretty certain about it.
Yeah, but you did say, you said earlier that the heavens are there to trick us, right?
That's how they were designed.
Yeah. So they were designed. So something designed it to trick us into thinking we're living on a sphere.
Yeah.
But somehow we can figure it out simply by just looking at things like the horizon. I mean, I don't understand. It's not a very good trick, then, is it?
Well, it is. It's the majority of the world still. Flat Earth is out there for years now, and it. Still, people just hold on to the globe concept because that.
If we go down that path, right? It seems like God is like one of the biggest tricksters in the world.
The designer is the biggest trickster ever known.
Okay, and essentially,
but he can't
the
pull
technology
you
that he had in order to create this type of illusion is far beyond the technology that we have today on Earth.
Well,
and
maybe not
if
for
we
long,
are,
but
if we are as children, why didn't you just give us a helping hand to get there?
Because we're not supposed to.
Okay.
So why are you trying to do it?
We have to figure it out ourselves. That's the path. And if we don't, then we just stay where we are.
So it almost seems like God then is a very technological.
I'm not saying it is God. I'm saying it was the designer, the one that actually made everything. That's what I'm saying. I'm not even saying he's still alive. I'm not saying he's human. I'm not saying anything. I'm just saying this is the nature of the design.
You're not talking about Voldemort?
I mean, you're making it very hard for us to understand. So there was a creator. You don't know what create. Sorry, you can introduce Riley.
Been joined by Sleeping Warrior. Very pleased to have you here.
Good morning, boys and girls.
Morning.
How are we?
Good. Thank you for being here.
It's actually lunchtime.
Yeah, it's just afternoon. Right. I apologise. When there's a break in the chat, I've got a choice for curved water to make, and I'm going to give him a proposition, and he can pick one or two. One I'll deal with today. The second one I'll deal with next time. So when there's a gap, just come back to me, and I'll just sit and wait until.
Well, we should just do that because I'm not really sure what Owen's talking about.
He's not the only one.
I kind of get it. I kind of get where you're coming from, but I give you credit, Owen, that you at least do understand the problem of the stars.
Yeah, it's a huge problem, and the main problems are psychological, and that is what we have been dealing with since the beginning. It's not even trying to get things to be understood by other parties. It's the psychological barriers that we constantly have to overcome with each other. That's the problem. That's the problem we actually experience in this.
Okay, are you done now? I'm trying not to talk over you. Are you done?
Sure.
Okay.
It's been a
What is this? What is this about the sun? You're talking about being not triangulatable. What does that even mean, Arwen?
The sun cannot be triangulated to be in a literal physical position on any model. That we know.
Where do you get that from? Because that's so false.
From observations from different people actually doing this. during the whole sun tracking thing that happened.
Oh my God, that's what we're going to. Okay, forget it. Forget I even asked, man.
Oh, fine.
I'm
Yeah,
not going
sure,
down that
sure.
road
Now,
with you.
now that
I'm
definitely
interested.
means
The
that I'm
sun-
completely discredited, right?
The
That's
sun
what
is
you're
easily
suggesting.
triangulatable from all positions around the globe. This is
I'm
nonsense.
no, hold on.
Yeah, well, if you don't want to
with
understand what I'm
that
actually
conclusion.
trying to say, then yeah, you can do
You
this.
can't. It's a trick, Arwen. It's a trick. You're telling
Yeah,
me it's
sure,
not.
it's a trick, sure.
You're telling me it's not where it is. So
No, I'm not saying it's not
Forget
where
it.
it is. I'm saying it's
You
not a
are.
physical
You are.
object.
You are. Well, and the point of that is it's in different locations for different people.
No, it's in no location. It doesn't have a location because it's
Okay.
a physical object. It only has
Okay.
apparent
Got it.
locations
Got it.
in relation to the observer.
Arwen's cracked the code.
Yeah, but at least it worked.
He's-
He can make it work at least on a flat
He's
disk.
beaten the trickster.
It's
Arwen
just-
has beaten the trickster.
I'm trying to.
Thank you, Arwen. Thank you for revealing this special knowledge to us. Appreciate it.
No, you're welcome. Do with it as you please.
Fair enough. Fair enough.
I have.
Anyway, we're going to do Riley's question. You ready, Curved? Dun, 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 dun. Do we need a drum roll?
Sure. Okay, I'm going to start with two assertions, and it's up to Curved which one he wants to go with. I'm good with both. Assertion number one. Brenda has presented on at least 3 occasions information or evidence that she cites to be credible, knowing full well that they're not credible. There is a fourth. Nathan may be able to help me with the fourth. I can't remember the fourth, but there's at least 3. I'd like to present the evidence of that and see where what people think about it. And alternatively, the second assertion is, when we were talking recently about the Lake Michigan and the skyline of Toronto from Jenna Frodo, I've been researching a little bit about that observation to see if I could find any more evidence to support the discussion either way. And I've actually got evidence of that same skyline, but done at night time. So in addition to my Blackpool Tower observation, the Jenna Frodo video has been done at night time, and I think you might be impressed and surprised with what we can see at night. Which one do you want to go with, Kev?
I'm not aware of any Jenna Frodo.
Fredo?
Can we do that one? The one that's like not about Brenda.
Not the Brenda one.
Not that I hate Brenda. I love
Yeah,
Brenda.
I'd rather not sit here and talk about somebody, not hear
Let's
like
do the one that's not about
this. And you're asking me to determine intent, which Riley.
No, I wasn't asking you.
It's about intent and proving intent.
No. I wasn't asking you to determine. I was going to present.
We're not going there.
See what people think. So which one? Do you want Brenda or Toronto?
Oh, Toronto.
Toronto. Let's be real, man. Most people would disagree with you in the chat anyway. So
Toronto. I like Toronto.
That's okay.
Let's just go for the
What is
Toronto.
this?
Nathan, do you want to share my screen so that it'll present to everyone so that it stays stuck on?
All right, now this is going to be key here, Riley. Do you have video of Nummy Num from across the lake, shot from Niagara?
Oh, I got better than Nummy Num. You know,
No.
you were talking about the what's that building next to it? The blue one. What's that called?
Oh, the Rogers Center.
The Rogers Center. Yeah.
Yes.
Well, this is in the context of the assertion by ballers that in some way this Blackpool Tower evidence that I took is not clear. And that needs to be re-rotated. It's in the wrong place. Just give me a sec while I get back to it. Rotate left, I think. So Jeremy and certain other ballers argue that this evidence here that me and Ranty took is inconclusive because you can't make out the individual features.
That doesn't look like Toronto.
No. So I thought, and bearing in mind we were looking at Toronto yesterday, I thought I'd have a look to see what we could find about the Toronto stuff, to see if there was anything more. So in my favorites, I saved some files, and I want to show you some long distance video time lapses. I think this is the time lapse one. And what this is showing is
shows a grandma.
Yeah.
What was that?
Now this is a bloke that's not using a P900. He's using something similar, but it's not got the same level of focal range on it. Yeah. It's not quite as good, but it's also not at the shoreline. So obviously it's a little bit taller. I don't know exactly how tall it is, but what he's showing is
from. What channel is this? All Blacks 420 or something like that?
Not sure, but what he's showing is look at the what's it called? This thing,
Rogers Center.
The Rogers Center, right? So that appears to indicate that that's what the Rogers Center looks like, but that's not my point. My point is in the description part of this video, it gives some more information, And what he says is he's using a Canon SX40, using a 2x digital zoom to film the city of Toronto from Niagara Falls. Distances are approximately 60 kilometers and 50 kilometers or whatever. But this is the bit I'm interested in. Here are some recent May 2016 nighttime photos of Toronto. Rogers Centre ceiling height is 94 meters. When we click this link, it takes us to his imagery. And this is what I'm most interested in. Let me make this a bit bigger so you guys can see it better. This is what I'm most interested in, because if we look at, obviously, forget the tower for a minute. Let's look at the Rogers Centre and see what features we can make of it. Obviously, this is the Rogers Centre, agreed. But we see these two red wheels. It looks like a car on wheels. And then when you scroll down the image, you can see what these red marks are. And this is the level of detail that you guys request all the time. And we appear never to be able to get it to your satisfaction. But in this article here, he shows that there's one of the red wheels, the Rogers Centre, and there's another of the red wheels, the other side of the Rogers Centre. Now, if it stands to reason that we can see this low, it stands to reason that we're probably also going to be seeing a little bit lower than that to some degree, but that's not that far off the ground.
Can you show me how far is it off the ground?
How far is it off the ground?
The Rogers Centre is something like 297 feet tall.
I haven't done the maths on it. I only found it.
Well, maybe you should. Maybe you should, if you're going to try to make a point like this.
You are quite right.
Regardless of all that, right? You guys understand refraction of light.
Yeah,
that's a separate issue.
Angular resolution limitations stop us from seeing certain things anyway. So I accept and concede that we're not seeing these street parade lights, these bits underneath here. So we're not seeing all the way down to the ground because it doesn't appear to be evident in the photo. But would you agree that we can see the red lights that are actually the name of it? Would you agree?
What kind of a question is that?
A black and white, yes or no? Commit to it or not?
Yeah.
So what's the elevation of the photographer?
I can see it.
What's
the
elevation
we can all see
of
that.
the photographer?
Either can't you? Can you answer a question or can't you?
Yeah, we said we can see it. We can see it.
Yeah, but I don't think we can argue that we can't see it, right? But the other thing to notice is look at the actual shape. Look how it's quite flat and squashed, which is convergence.
Which is an indication of refraction.
Compare the shapes. No, it's an indication of convergence with the horizon.
Refraction.
No, it's an indication of convergence with the horizon.
You're making something up. You're making up something.
Anthony,
no, I'm not making up. We know that things converge with the horizon.
Anthony, there may be something else at play here, because this photograph of the center that you're talking about, it's actually photographed from an angle.
Yeah,
tends to widen the globularness because you're looking at it from an angle. While if you'd looked at it from a perfectly horizontal position, it would look different. The more you go up, the more curve it gets.
But
roundish it gets.
Would you guys agree? Even if that was the case, it wouldn't be obscured in that manner. Right, it will be a more linear.
No, Alwyn makes a fair point. It is on a different angle, but would you agree, Alwyn?
You don't know the angle. You don't know the angle.
Alwyn.
I'm looking at a picture of it from head on, and it does look a lot flatter head on.
Yeah, it does appear to be flatter. Would you agree, Alwyn?
Yeah. Yes, exactly. This is from a 30-degree angle downwards.
Sure, and I'm totally with you. The other thing
is perfectly a zero angle view.
The other point to make about this is, if you notice on the original image here, you can see that there is where the red bit is here. There appears to be something like a square that's here blocking out the remaining part of the building. Can you see the square? Because it looks like it should go over in a continuous teardrop and come back, and it looks like there's a square in the foreground.
I don't know. There is an obstruction. I don't know what it is.
And now look at what we see here. It looks like this is the square that we're seeing, but we're obviously seeing it on a slightly different angle, but it looks like it's chopping off this corner bit. So obviously this looks like it's been taken to one side, but that looks like it's the thing that's blocking off.
How do you say, the direction may be different.
Sure, that's what I'm saying.
This is like a 30-degree around the building towards your right hand, watching at the building from close up, compared to this photograph, which would be 30 degrees to the right. So the building would move in front of it.
Agreed. But my point is, there's further evidence that at nighttime we get better levels of observation that support the claim that there is no apparent curvature. Now, what I'm going to do?
Wow.
No, you guys, at nighttime,
Can't see the bottom.
Humidity is a lot less at nighttime.
Yeah,
He's showing
so-
clear
so
obstruction still doing
refraction's
a
a lot
victory
less.
dance.
If we do,
Refraction is a direct derivative of the amount of matter that's in the air.
sure.
And at nighttime, when the air is less dense, there's less matter in the air.
Temperature is the
then-
main driver of refraction.
Let's
Temperature.
do
gradient.
the.
I
Let's
don't
do
know
the
if
distances.
refraction proves lack of curvature or anything.
Just
I
Okay.
just know
You don't
that
have to know it, Arwen. You
Guys,
don't have to
guys.
know it for it to be true.
Guys, let's just do some the maths for those that are not sure about what's being shown here. But the distance.
Hey, Riley, how did I know the channel name? Remember, I asked you if it was All Blacks 420. You said you didn't know. Boom, there it is, right there.
All right, guys, if we
Hang
really
on.
want to do the math, right? God,
Let's
dude.
do- Let's do the maths and then I'll address your question.
So, first of all, we've got to figure out the index of refraction on that particular day of night, right?
You
We've got to
can't.
figure out the density of air at
You
that
can't.
particular time.
You
And
can't.
based on that, we can derive the index of refraction.
we
Based
don't
on
have
that,
the
we can derive.
information to do it.
I agree with that comment. We have to look up the pressure. Oh, get rid of that. We have to look up
Just
the
out of
pressure
interest before you
variation
go
and,
on,
the gas,
Anthony.
the ideal gas law, because this is what standard refraction is meant to be based on. Because it says so here, standard refraction is an
Standard
approximate.
refraction.
However, he calculates it based on that. So this whole paragraph here is based
is
on
an approximation.
Can you please let them guys speak?
Guys, can I just interrupt for 1 second? I assume from what Curve just said, knowing the channel, does that mean you've already done this maths, Curved?
No, I've seen the video. I recognize it.
Okay,
What's his elevation? Is that information given
Well, that's what I'm going to try and find out.
and
It says,
verifiable?
Right,
Because
can we all
without
just-
elevation,
can you
there's
just, can
no
you just
point
let him
doing
get through
any
it then?
math.
I'm sure it'll only, without him being trolled by 4 people, I'm sure he'll just get through it pretty quickly. But if I can, I'll just say a quick hello to Negator XX, and then hopefully Sleeping Warrior can get through the end of this, do the maths, and then you can sort of attack it afterwards. Hi, pleased to have you here, Neg. We'll do that after. Feel free to carry on, Anthony.
It looks like the distance. It says digital zoom to film city of Toronto from Niagara Falls and Niagara Falls on the lake. Now, I'm not sure whether he's at Niagara Falls or Niagara Falls on the lake when the picture's been taken. So this is where I'm going to have to kind of bat it back to Curved, because I don't know what the facts are, and maybe if he did a bit of research to it and we can come up with a conclusion that's based on both of us working it out. But it looks like he's got 60 kilometers and 50 kilometers, but we don't know what his observer height is. So it looks like we're going to have to do a bit of research to work out where he is, because he doesn't make it clear.
Apparently, he has a claim in the video, in the description, either in the video or the description. I'm not sure which one.
But my point is that we see a lot lower now. The I mean, I don't know where where it's meant to be. I think it's up here somewhere. But
Anthony, nobody's disputing that refraction can make you see more than straight math without refraction allows you to see. Come on now.
But you guys do dispute that refraction is not based on proving a curve. You mean you say that refraction is explaining it, and it does explain it, but refraction itself is subject to proving that the surface that we're looking at is curved. If it is proven to be curved, then yeah, refraction is a thing. But you can't claim it's refraction unless you can prove it is curved and it just appears to be flat.
Well, dude, if you would look at all of the video that's available from the same basic location showing, 300 feet or more of obstruction, then see, refraction explains how we can sometimes make these anomalous observations. What do you have to explain all of the videos out there where the obstruction is there?
Well, I haven't seen a lot of videos.
What is your explanation when it's not there?
Yeah.
I just gave it to
No
you.
consistency.
I just gave it to you, Erwin.
There should be a perfect consistency.
Curved,
Hold
listen.
on a second though. But what you guys said is completely wrong too. Right? Because refraction, even on a flat plane, because your index of refraction is going to change based on how high you are over the water. So we're not talking about a level density of air. We're talking about a gradient level of air. So even on a flat plane, the light will bend.
Yeah, but my point still stands that if the argument is that refraction explains it, then we can only accept the explanation if you can prove that it is curved and it appears to be flat. Because if you can't prove it's curved in the first place, you can't argue that refraction explains it credibly, because it's subject to proving that it's curved. Otherwise, it's just an illusion. Mathematics.
Big shout out to Daylight, Ohio.
Tumbleweed.
Smashing that super cat. Good work.
Yeah, no, I mean, seriously, even if, okay, so we're talking about if it was on a flat plane, right? And we're looking at that and we're trying to say why we're seeing what we're seeing. Why can't you see the bottom? Why can you only see those little red lights? Why can't you see the bottom of the building?
There's three factors what affect why we can't see the bottom. The first is convergence with the horizon. The second is the angular size resolution limitation. And the third one is the atmospheric optics of the day.
And don't forget just universal obstruction.
I thought we were talking about Toronto. Why are we looking at this?
Because I'm reminding you what we see.
Will give some level of obstruction.
I'm reminding people that when we see refraction day to day, this is all we see. We're not seeing the curve. We're just seeing
that's the entirety of refraction right there. That right there is the entirety of refraction in the history of the world.
That's all refraction is, unless you can prove that it's bending behind the curve and bringing this mountain back into the foreground. Exactly. And refraction is literally the variation of the vertical axis. It's not a representation of the z-axis or the x-axis, like through looking from the z-axis. It's not reflecting the z-axis.
There's no curve there.
No, there's only stretching and shrinking, stretching and shrinking.
Exactly. So
yeah,
if there was a curvature, if the Earth was a ball, then it should have consistent curvature with only minor visual changes because of perspective. But there's not.
On that picture we just saw, right? We see the coast.
Which this one on screen now?
Yeah, we see the coast. So we basically see the seashore.
That's in the foreground, though, right?
Yeah, but we see the seashore, right?
Sure.
So then, when we look at that Toronto picture, shouldn't we see the bottom of the building?
Well, we know that that's on the horizon, whereas this isn't on the horizon, right? This is in the foreground. So the Toronto one, we know that that is on the horizon. It's right at the point where we can't see any further, whereas the shoreline...
But hang on, we can see further. We can see the buildings behind.
Well, how far off the shore?
You could probably see a little bit further.
The shore is closer than the buildings behind the shore.
Sure,
so we can see as far as that. Atmosphere is allowing us to see that.
Tend to have more air pollution, so it will make it less likely for you to look beyond it.
Yeah, there's three factors that influence why we can't see the absolute shoreline. One is the angular size resolution limitation. Two is optically the atmosphere that we're looking through, because you are effectively looking through water when you're looking through the moisture in the atmosphere. It's not Snell's law. There's not a difference.
Car exhaustion particles. They will definitely obstruct visuals.
Yeah, but I've never seen any image. I've never seen any image obscured by atmospheric conditions. You know, on like a long road that like pushes the image down and into the ground.
Well,
I mean, you got to
understand to create a false horizon. Have you ever?
Understand that what did you just for atmospheric pressure to cause that difference in refraction? It's got to be a substantial amount.
What did he just say about the road?
Density.
Well, I said I've never seen like a long road that was straight, or like that I could see like further down, like usually, and then atmospheric conditions for whatever reason, like hot day or whatever, a lot of moisture in the air, like that's creating a lot of these images, like squash the road and create an artificial horizon where there isn't one. I've never seen that.
All right. What about this one?
Yeah, but this bridge is curved. This bridge is bent.
No, it's not.
Well, yeah, it is, because you can see further off into the background as well.
But we see here exactly what we see with Soundly's image. We see that the Pontchartrain stuff appears to basically bend off following the curvature of the Earth.
But is it? Because I'm still seeing like the road. It's like messed up. This is what I'm talking about. That's the sort of thing I would see.
A mirage. That's actual heat you're looking at.
Look at the barrier now. Is that not exactly what we see with Soundly?
Hey, quick check. Can I be heard?
I suppose it's not a bad point, but
am I coming through?
Not really, no, because it's all curved and it's not like a solid.
Are you kidding me?
No, I am not kidding. You look at it; it's all split up and it's all mashed up, and it's changing drastically, like in the way you see things as you move around. Whereas that's not what we see on the sea. We see like a perfect straight, like a perfect straight or curved or whatever, however you want to look at it, but a perfect horizon line.
Right. Just comment. Really can you comment on the last 10 seconds of this and tell us how this is different to Soundly's? Just watch what happens.
Dude.
A curve.
Just watch.
Nothing like Soundleaf.
Curve.
Yeah.
You like Soundleys.
Can you
It's
hear me?
nothing like Soundleaf.
Hey, can somebody tell me?
It's exactly the same.
Can I
Maybe
be
I'm thinking of the wrong video. I don't
No,
know
no,
what
no,
Soundleaf
watch.
video.
Come
you mean.
on.
Watch. With regards to his bridge, all the telegraph poles, the power cables that go over the water, they both do this, right? Watch. There you go. Should we get it on screen? and
No,
compare
they
it?
don't. Look at it, Riley.
do.
Look at the thing. It's flipping round. It's
Let's get it on screen and compare it.
Look how it's changing. It's like flipping round and mirroring and stuff.
Let's get it on screen and see whether it's comparable.
Yeah, get it on screen.
Sorry, guys.
Right,
can
so
I
we
just
want-
check that we
In
can
the
hear?
reflection
Sorry,
itself,
sorry,
where
Arwin,
is
bear
the
with me.
mirage
Arwin, bear with
reflect?
me. I just want to check that we can actually hear curved water and negator XX, if you don't mind.
Can you hear me?
Yes, we can hear you perfectly.
Okay, thank you.
Can we hear you, Neg?
There we go.
Yep.
Neg might not be able to talk too much right now.
Oh, okay, fair enough.
He's doing a lot of typing.
So where
Thank you.
in Soundly's videos does the bridge flip around and curve and mirror?
Well, I've only found the one with the it just happens to have been the one I found. But can you not see that the railings?
Yeah,
that we know are
can you not
straight?
see the bridge is flipped and mirrored there? It's giving a mirror image, like a mirage. Can you not see that? I don't know the technical terms for these, but look, you see with the bridge
It's a
suddenly
mirage. It
flips
is
back.
technically a mirage.
Is that what it is?
Oh,
Yeah.
Yeah, but that
Because of
flipping back
heat.
is
You can
evidence
see it
here.
before. There's heat waves. This makes mirages possible.
All right, Riley, do you see my video? Do you see what I'm showing right now from Niagara on the Lake?
Hang on,
Where
let me go back
Kratos-
to the chat screen. Hang on.
I'm trying to see. Is this what you're trying to explain with these bendy flats?
I'm sorry, you'll have to clarify your point that your question.
Yeah, your wavy bridge. Is this what I'm showing on my screen right now?
I'm looking at
Does
it. See it.
Does it look familiar? Do you see what I'm showing?
Yeah,
Where's the Rogers Center in this pic? This
it's
is
behind that band of refraction that's sat on the horizon.
what is the band of refraction that sat on the horizon?
The thing that's blocking the Rogers Center.
Okay, there's really no point in discussing any of this with you if you're gonna say things like that.
Yeah, but the thing is, we can see that refracted
You're
light.
dodging reality, Riley. You're dodging reality, dude.
No, I'm not. What I'm pointing out is that if we go back to my screen, Nathan, just present mine back again. The point I'm making is that there was an assertion by the guy that was just prior to this that said that we know that things are flat and Soundless is clearly curved. But I've just given you evidence where there is something that's flat, but it gives the appearance that it's curved, and we're seeing that band of
No,
refraction.
but
on the
dude,
horizon.
it's giving the appearance of a mirage. It's literally flipping around the bridge.
So how can you
see that?
contrast that against Soundless?
Get
Because
away-
Soundly's bridge isn't flipping around and
Hold on.
mirroring itself, is it? Yeah,
It is.
Hold on for a
Where are the
second.
power lines turned
Hold on
upside
for a second. Hold on. Why are we discussing the bottom of this image down where they want to cry about reflection and mirrors and all that kind of stuff? What is curving the top of the towers downward?
The atmosphere that the things are sat in, and it's evidenced by this. Because we know that, let's just go with the notion for a sec that it is a flat Earth. Let's say that water is flat. Now, we all
Atmosphere
assert
is
it.
curving the top of the towers downward.
Yeah, but it's atmospheric.
That
Can you not
is
see that?
not atmospheric curving. Where do you get this from?
Well, you know that the atmosphere is based in layers because it says in the Metabunk site, it says here, when you click on standard atmospheric conditions, it says clearly, black and white, the International Standard Atmosphere is an atmospheric model of how the pressure, temperature, density, and viscosity change over a wide... Hang on, where is it? There we go. Divides the atmosphere into layers with an assumed linear distribution of temperature against altitude. This is what we're seeing. We're seeing a layer of the atmosphere that we can't normally put anything in because, I mean, yeah, I agree that Soundly's works quite unique because we don't have many things that are over water ordinarily. But we're seeing the same thing here, this layer in the atmosphere that gives us what he gives us here.
Yeah.
I don't see how that can be argued.
It's the same type of effect. Absolutely.
It doesn't do what you're claiming it does. This is absurd.
You're right. It is absurd, but it does appear to do what I'm claiming it does. Because
So I hope you are all enjoying the show so far. I'm going to do a couple of links as we have around 30 minutes, maybe a little bit more left on this live broadcast. If you are new to the channel, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, as They Lie Ohio did earlier, come on, you little trolly monster. Feel free to hit that super chat and donate to the channel. If you would like to join the show, most importantly, there is a link in the info box below this video with the page you are currently watching the show on muted. Click that link to join the show and express your views on the shape of the earth. There are only a couple of rules. Number 1, please do not swear. If you do, you will be ejected. Number 2, if you are ejected, please don't try to rejoin using sock accounts. You will be warmly welcomed back on the next stream. Are you agreeing? If you've not done so already, please share the show on social media. And one more time, if you are new to the channel, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate.
What about what I showed?
So, well, you asked where was the Rogers Centre?
Here, I'm going to
And
show it again,
my answer
Riley.
was the Rogers Centre is behind, like, I mean, look at this one. Look at this one here.
Water, Riley. It's
So
behind the
where are
wire.
those? So where are those lampposts like flipping down then and coming right down below the horizon? If anything, they're just mirroring and stretching down. They're not like being squashed down, are they? All those lampposts. They're still
Well,
where they
we've
should
just
be.
worked out refraction.
No,
In this image here, you don't
It's
have
not-
300 feet hidden behind some atmospheric banding layer.
No, you're right. This is
it's
only
C,
so much.
isn't it? It's
You
not
don't
mirror.
have the room.
But the
You-
problem
you
is,
picked
though,
water.
if this was longer, now it's not, obviously it's not that long, it's long enough, but if it was like 19 miles long, the tops of these would do exactly the same as what Soundless has done.
Where's the Rogers Center here, Riley? Where's the Rogers Center?
It's behind that refraction that
It's
I've
behind the
illustrated.
water.
But that
It's
doesn't
behind
show
the
you
water,
things
Steve.
being pulled down behind the horizon, does it? That's what.
Yeah, it does.
Refraction.
No, it doesn't. It's being mirrored down. It's not being
Can you-
pulled down.
Right, are you still seeing my screen?
Yeah,
at the
those
moment?
look at the top of the lamppost. They're
Do
still
you not see how this pulls it down?
No, look at the top of the
No, it's a
lamppost.
reflection, actually.
Look at
The top
Can
of
I
the
make the
poles
point?
are reflected in the
Yeah.
mirage downwards.
Yeah.
That
I mean,
is true.
the top-
And that gives an apparent curvature effect.
No,
in
it
some
doesn't. Look,
circumstances.
the top. Look, we're talking about the top. This building, the Rogers. Yeah, there's loads of stuff missing. If this was the case, that you'd still see the bottom of the Rogers, and it would be stretching down, because the top is still where it should be. The top of the lamppost in your picture is still where it should be.
But the other Jenna Frodo video shows that that's exactly what the Rogers Centre does, right?
No, it doesn't.
What other video?
No, those lampposts should be squashed down, Riley, because the point is, why are we not seeing the bottom of something? And you're saying because our atmosphere is squashing it down or something.
There
No,
is
it's
It's behind the
Yeah.
horizon. It's not mirroring.
It's a local, the mirage effect.
a local
Yeah, there's still
mirage
space.
set.
If you
Just
Derp it out
cuts off.
already.
right,
It's-
think of it this way: if you
because
were
of the heat, there is just
Derp it out.
there's this flipping point where it just
Okay.
turns, and you get all these
yeah,
weird
exactly,
phenomena.
exactly, Owen, exactly. So imagine if you wanted to just redraw, just in 2D over the top where the bridge should be and where everything should be. It should just still be there. You're just getting a mirroring effect. You can't do that with the picture of the obstruction of the Rogers Centre. You can't draw everything in where it should be and say, well, this is just a mirroring effect, because it's clearly C, isn't it? It's not mirroring.
Yeah, but can you?
It's a
But you can
sea
see-
level. It's a line
You
of
can
sea.
see the Rogers Centre's present on this image, but you can also see that it's cut off by the band. There's a line that goes across here, and then you see another dark band line, and then the bottom of the line.
And that is nothing like the picture you just
It's
showed us,
exactly
is
the
it?
same.
'Cause it's a
It's
mirror.
very
No,
strong.
it's not. It's a mirroring line you're showing us, and that is a band of dark blue.
No, what I'm showing you is the effects of refraction, and it's comparable
It's
identically
not
to the thing.
comparable, is it? Evidently, it should be. What you should see is the top of that Rogers building, like just going down, shouldn't you? Like you see the lamppost stretching.
No,
You should
it's
see the
not the
Rogers
same
business.
condition.
Well, there you go. So it's not the
You know
same.
what-
It's not
This
comparable.
is a very thick air moist place. You don't get the typical refraction thing, which is only in a clear sky with heat.
Okay,
That's when
Arwen.
you really get the reflective stuff. It's only in a clear sky
Arwen.
on a hot day. Otherwise, you'll
Arwen.
just get blurred up.
Yeah.
in
So if it's not
Okay.
reflective and it's not
This-
mirage, it's the
Our
sea,
way.
isn't it?
fluffy barriers.
This is a Jenna Fredo video right here from Olcott, New York, 39 miles away. Now, you've got good viewing conditions here. You've got a good, sharp, clear horizon line of the water here.
Yeah,
This is a video from Jenna Fredo.
yeah, I know.
Okay,
There's
remember that.
waves in between.
Yeah,
Waves.
and also that you
Yeah,
see
waves.
No, we're not
Sea
talking
makes
about
waves.
waves here.
You
We're not
can't get around that.
The
They have
waves
they
are
have
not
a height.
obstructing 600 feet of the city, Arwen.
I wouldn't say that's 600 feet of obstruction.
Of course you wouldn't. But then again, when have you been known to be honest? Look how much of the tower is visible.
When I present evidence contrary to your opinion.
Look how
not
few
opinion, it's a
buildings
video.
are visible.
There's a video here. It's missing.
This is crazy.
He asked whenever I've been
This is-
shown to be honest, and the answer is
Listen to this.
evidence contrary to his opinion.
Look at this. Where is the?
I
where's
don't
the
know why it
there?
looks like that. It does look weird.
Okay,
It
then
does
quit
look
making up a
like
bunch
the
of garbage
Yes,
about the other
bulging
videos. You
connection.
don't know.
Hang on. The obvious explanation would be that it's that band of refraction is the dark waves that's blocking it out.
Oh god.
You just can't see where the bottom of it
Does
is.
everybody hear that?
Can you
Is there
demonstrate that?
anybody out there that takes Riley seriously now? Did you hear what he just said? This is clearly the lake right here. This line
Well,
is
how do you
clearly
know?
the
It's
lake.
blocking the horizon.
This is the lake. This is
Well, I
water.
would argue
I don't know what I'm
Your-
seeing in
Your
that
example
picture.
does not
If you don't
account
know
for
what
that,
you're
Riley.
seeing, then maybe you shouldn't be involved in the
This
conversation.
picture
It doesn't
looks
get
like
much
a
plainer than
zoomed
this.
in close up. So
Right.
you don't know what you're actually seeing here. I don't know.
Oh, get out of town. This
Dude,
is
you're the guy talking about
ridiculous.
holograms of the sky.
Holy
man.
cow.
You
What?
Don't know
Maybe
what
you
to
don't know
say. Here,
anything.
watch it
Gone
again.
out of it.
Watch it again. Look how when she zooms in and it doesn't bring back more of the tower. The tower just grows proportionally. That's it. That's it. Look how little of the skyline is visible.
Yeah.
Look at this.
Yeah.
Look how clear the
Another killer.
horizon line is.
Yeah,
you,
it's
you
called
don't have
obstruction.
any mirrored.
Yeah, it's called
Yeah, it's
obstruction.
called obstruction. That's right. That's
It
right,
does
Arwen.
go above sea level because of waves.
Did you take a course on how to argue against yourself?
So water doesn't always find its level then.
No, it
No.
doesn't, but doesn't mean it doesn't
when
wave.
it's
It rocks.
Little
Water
waves
rocks.
on Lake Ontario are obstructing like 600 feet of the city skyline.
No, but if it's very close by, then just a few feet will actually block
Not
a
if you're-
lot in
Not
the
if you're
distance.
above the wave, Arwen. Not if you're above the wave.
Are you?
how-
I don't know. I don't know from how high this
Right.
video is
Does
taken. I
anybody
don't know
have any
anything
news
about this
reports
video.
of the tsunami on Lake Ontario? Anybody? Anybody got news reports of that? Arwen's claiming tsunami on Lake Ontario.
No, I'm not claiming tsunami. I'm just saying
Yes,
that.
you are,
Hey,
Arwen.
can you please let me finish?
Not
One
really.
damn second.
Ooh.
Yeah. Ooh. Yeah. Shut up. For a moment, okay. Waves. They take a certain height, and if something
What's the
wave
certain height,
is
Arwen?
very.
Be
Can
specific.
you let me finish?
Be specific.
If
You're
a
derping.
wave is very close by you, then its height in the long distance will obscure a lot more from
That-
view.
Yeah,
That's
because
how it works.
Because the Earth's
Arwen,
curved.
that's only even true to begin with if the wave
It
is
is
higher
true.
than your
Come
eye
on,
level.
it's basic perspective. An object
it's
close
not
to you
basic
will
perspective.
obstruct a lot more in the far distance
No.
than an object in the far distance.
Arwen,
obscuring
if
your view.
the wave is below your eye level, it's not going to be obstructing
You
things
don't know
higher
what
than your eye
level it
level.
is.
What are you,
You don't
talking
know.
about? Arwen, please. You're making a fool of
Curve,
yourself.
please stop.
You're making
talking
a
like
fool of
that to me,
yourself.
okay? It's basics. If something is close by and it obstructs you, it will block a lot more in distance than when you observe that same object with the same height
So
in the
did she
far
get hit by
distance.
a wave after that
Basic
video? Is that what
perspective.
you're saying? She got hit by a wave after that video. It was really close to her.
To be fair, what
The
he's
wave.
trying to say,
This-
what he's
Wave
trying to
close.
say, the waves in the foreground are bigger than the thing in the background.
Yeah, but we're looking to make up a lot of missing buildings here. He's explaining with the
Well, it
wave.
depends on how big the waves are. That's what his point is.
Yeah, they have to be
If
pretty
the
big.
waves are below your eye level,
Or it's
they
really
can't
close to
obstruct
them.
You're making
above
that
your eye level.
statement. The waves are
But you
below
said-
your eye level.
You said if
No.
it's close to you, it doesn't have to
Have
be
you
that
ever
big. So the waves are really
stood
close
at
to
the
you.
sea when the sea is rocking?
Not
the
if
waves
it's
go
flat.
way above sea level. It goes
This is a
up and
major
down.
failure
Rocks.
of a simple concept.
The average of the waves is the middle. That's the sea level. When the sea is getting wavy, the actual waves go above the sea level and under it. That's how waves work. There is obstruction there. And the closer the obstruction gets, the more it obstructs from what you see in the far distance.
Arwen.
He is right,
Arwen.
Curved. He is right.
No, he's not right.
Yes,
If
I
the
am
earth
right.
if the earth is flat and the water is flat, A wave
I'm not
that
even
is
discussing
lower than
that.
eye
I'm
level
just
is not
discussing
going to
perspective.
obstruct
I don't
things
care if
higher
it's
than
flat
your
or
eye
hill.
level. It's simple geometry. This is simple geometry. You could draw.
Obstruction. It's basic
Spurs
obstruction.
Chemo
When
could draw a
something's in
picture
the
of
way,
this.
you don't see what's behind it.
Spurs Chemo could diagram this.
I think this is just it doesn't even really matter in this because the waves are either really close to her, which obviously wasn't, or it's big if that's your explanation to make up for that much.
In that one picture, in that one video where the waves were obstructing, you could literally make out the physical surface shape of the waves, which mean that the actual waves that are obstructing are pretty close by.
What do you mean by that? You can make up the physical surface shape.
You
of
can
the wave.
see the reflections of the waves. You can see the actual shape of the waves.
In the picture I saw, I mean, I didn't look at the video that carefully, I guess, but all I saw was it not really moving, dipping up or down. So
no, you don't see that.
Well, that's what a wave does.
Because there's more than one wave.
But they come in waves.
They're obstructing each other. It's like a field of grass.
They're just all creating this bulge.
Grass thingy is sticking up, and when you look exactly at the bottom, you look past it. It's just like a green wall.
So, Owen, if we did the maths and we had all the things and the maths worked out correct to the globe model, then what would you say, that the waves are always just so happen to be in the right place for the globe model?
I'm not even discussing the Earth shape. I'm just discussing perspective.
Okay, but this is the flat Earth debate, man.
Yeah, but perspective is a big
but it's useless when you get into that.
But it doesn't explain what you're using it as an explanation for this picture, and I
like perspective.
Well, we're discussing the
using
perspective.
it incorrectly. He's making false statements about the perspective.
Well, I mean, if that was the case, then at night, you should be able to see less of it, right? Not more, because the moon's pulling the water up even more.
Don't get what you mean, bro. You mean like
I don't know.
Like at night you get high tide, right? So the water level is a little bit higher. Yeah. And your waves are essentially gonna be a little bit higher.
But he's not talking about tide. He's talking about the wave, isn't he? Big
I know,
wave.
but essentially, the original point was the fact that at night you can see more of the buildings in Toronto.
But that's
whereas
not always
if we're talking about straight the waves causing the problems, then at night you should actually see less, because the moon's going to be pulling the water up a little bit higher.
The moon doesn't do that.
This is variable.
That's
you don't have a consistent view.
Heliocentric physical object literalism. So
I don't know, man. I'm trying to.
The moon does not
talk like you guys are talking, like with this odd scientific methodology.
There's nothing odd about it.
All we can be certain is that the tides is the phenomena that the sea is being heightened, because there's water coming from somewhere for some reason. That's the only thing you know with absolute certainty. What causes it, you don't know.
It's a lake, Arwen. This is a lake. The waves only get so high. The photographers are above the waves.
And at night, they would only get higher.
Stupid. This is stupid.
At night, they'll only get higher. They won't get less high. There's no way. If you're talking about...
The photographers are above the waves. End of.
I don't know if they are.
It's not the end of, though.
I'd have to actually see the setup of where the camera is, and like from another angle, just see what is that setup of that video that we just saw. Because as far as I can see, the camera was placed pretty low.
Well,
like
that's what you need.
High in front of the coast. So.
Yeah, but is the wave moving? Is it going up and down? If it's a wave.
It might be, but you wouldn't see, because there are so many waves that they, like, when one wave goes down, another one will be in front of it while that other wave goes down. So they're all you're just seeing tops of waves.
Right, I know exactly what you're trying to say. You're talking about the average height of waves is not even the average, the peak height of waves.
Exactly, it will obstruct.
It make a big bulge.
But what I'm trying to say is it makes no sense, because you originally said that at nighttime you could see more, and that can't be the case, because at nighttime...
That was all Anthony.
I said that, and I stand by that, because it supports my Blackpool Tower observation at nighttime.
Oh, at least we know why you support it.
Yeah, you're right. You said that.
Here's the glitch I
Yes,
have.
yes. I'm sorry, guys.
Here's the glitch that I'm seeing. The one
Still a
with
good point.
the tsunami, with the one with the tsunami picture that Curve showed with the antenna that's exposed. Now, if we are looking at this in a sense where there is an obstruction and there is no obstruction and there is declination in there, and it is a spherical model, shouldn't we see that antenna be pointing away from us or towards from us as if it's going down?
Who's talking?
Green.
Is that
Warrior.
Cy? Okay,
Yeah, it's me.
my screen's kind of like frozen up. I'm stuck on a video that says skip ad, time lapse, splatter.
No worries.
I'm
But I'm
clicked
just,
on
I just
right.
wanted.
Okay, so here's the deal with that, Cy. Okay, over these distances, 30, 39 miles, you're looking at roughly one half of a degree of
Yeah.
tilt. And it's going to be tilted away from you, regardless of where your line of sight is. Looking at the building, 1/2 degree roughly away from you. Now, you can't detect very well tilt towards and away from you.
I agree.
Take a fence post, stand it up, move it away from you, and back up and look at it. Pull it towards you a little bit, back away, look at it. You can't see that variation, not a little 1/2 degree. And that's the simple answer. I'm not going to try to over explain this. It's very small.
No,
It's very easy. Yeah.
It's in a direction that's
but what I'm seeing here is the glitch is that even though it's so small, but what we're seeing here is a big swell of a wave. But now what we're not seeing is the building. It's just the actual antenna. So it just looks like it's more than what it's showing. It looks like it's more than 1 degree. But if it is, let's just say, for example, hypothetically, if it is more than, let's just say it's 5 degrees or it shows declination.
Can I address that? Can I address that? Let me go ahead and don't mean to cut you short, but to the point. See, here's the deal. When you have a distance of like 30, 39 miles, 1/2 degree, how much height is that? You see what I'm saying?
A lot.
Well, no, let's go by feet. If I have to do 39 miles, it should be like, what, 2,000 feet around there, I believe. I'm just guessing. It should be around. So let's just say 69 miles is what? About
Kind of double what we could normally see in the atmosphere.
The curvature of the official globe model should be extremely visible and unavoidable, and that's not the case.
We just showed you a video with it. You can see it.
No, but it's not enough. No video out there actually shows enough curvature, except for the NASA videos.
I just showed you one.
Well, we just showed you the curvature. You can't escape. And you're talking about big
with
waves.
how much the curve should actually
Which
be.
would create a curve, right? If there was a big wave. So
Just because there seems to be a curve of some kind doesn't mean that it actually lines up with how the globe curve should officially be.
Yeah, but nobody believes it's a big wave, creating that curve.
Listen, Arwin, you can push your sentence one step further and say, not only is there not enough evidence to support the curvature, it should be on every single observation. It should be consistent from everywhere in the world.
But there's this other thing that there are variations in this apparent curvature that we see due to optics, refraction, all that stuff. But the thing is that according to the official globe size shape, the curve should be a lot more than we get to see in any observation. We may see
most of the skyline missing.
Never enough according to the official globe model.
Never. You just saw most of the skyline missing, Arwin. You've just seen a video of that. That's a lot of curve.
A video with apparent curve, but it's not enough according to the official
It's not enough for
model.
you. But you can take this video any day, every day, everywhere. These same videos. So there's tons.
You can keep
as many as
saying
you want
that, but the apparent observed curvature does not match up with how much
so
curvature
Owen, I'm
there
confused
should
now.
be.
Owen, do you believe there's a curve or you do not believe there's a curve? Because I'm hearing two things from you now. First, you don't believe there's a curve, and now you believe there's a curve, but it's not as curved as we think it is. So which one do you believe?
I think you might be on mute. But if Arwin's not going to come back at this point, let me ask, or let me point out one thing to you guys that may be lost in comparison, because, or maybe lost in conversion, because when I was discussing this exact point with Mick West, personally with Mick West. I need to share my screen so you can see it. So let me go back to it, which would be the. Oh, give me 2 minutes. I'll be back.
Well, Riley's talked to us personally with Mick West. That's Mick West on the phone right now.
And also, a real quick word to Cy while he's doing that. Cy, with the 1 degree thing or the half a degree thing and all that, it doesn't work that way when you're looking horizontally. Like 1 degree of the Earth's surface does not give you 1 degree drop from your horizontal line of sight as well. I just wanted to make sure I got that in there.
Well, the further it's away, the more exponential it should actually be turning away from you.
What?
Because that's what curve does.
We're forgetting.
The object does. The further it gets away, the more it
I'm
going
to
changes its angle towards you.
I'm going to make a suggestion that we're
away from you.
I'm going to make a suggestion that we're distorting the scale significantly here. Mick West said to me on one occasion that he recommends this particular paper for understanding the effects of refraction in a detailed level. He then gives us this link here. I don't have it to click so that I can't provide it. You'd have to copy it out letter by letter. But when you actually click this link, you get to one of the paragraphs, which is this one, from within this link, and it states that under certain circumstances, the effects are negligible, okay? And we're talking about refraction. It's under non-standard circumstances when we see some amazing atmospheric phenomena. Probably the best known is the inferior mirage, which occurs when lower regions of the atmosphere are much hotter than higher regions, as in deserts. Since the index of refraction is an inverse function of temperature, light beams get bent upwards, and what we see on the ground is actually the image of objects above it. But notice that it doesn't describe the really amazing atmospheric phenomena, like seeing around the curve of the Earth. It describes the effect of refraction as negligible. And then when you look up the word negligible, you get presented with this word. Negligible says that it's so small.
Insignificant.
Yeah, we know what negligible means.
Not important in the
So let's keep the effects of refraction to negligible, because we can't account for it being huge amounts. It is not worth considering. So you can't really argue that refraction is explaining things that are so massively different to what we're expecting, when Mick West's own authority says actually the effects of refraction are negligible.
But aren't you trying to say refraction is what's causing us to see all these mad buildings dropping down and we're not seeing anything? You know, that's
no, we're saying it's the lack of curvature that's causing us to do that.
No.
Pontytrain.
You would see it, Riley. If there was lack of curvature, you'd see the bottom of things, but you don't. So what's the
and we've addressed that concisely. It's the angular resolution size limitation. It's the atmospheric the optic.
What does that mean? Angular resolution size limitation.
Angular resolution doesn't
half of the object.
If that was the case, you wouldn't be able to see those little red lines, because they'll be minuscule.
Okay, so what do I mean by the angular size resolution limitation?
No, everyone knows what angular resolution is, dude. It's when something gets further away from you, it gets smaller.
Yeah, correct.
But it doesn't cut its legs off unless there's some atmospheric conditions
to
create that. So what is your atmosphere?
Look how small the sign is here on the building that we looked at before. How small do you think that the streetlights underneath would be in relation to the size of the sign? I mean, there's the Rogers Centre sign.
They're about the same from this picture. About the same.
They're tiny. But
look at the thickness of the glow there, of what's glowing, glowing.
Yes.
It's very thick, so we should be able to see that. How is that getting squashed out?
A lot of light there.
It's the angular size. It's the angular size resolution limits.
All the cars driving past with their lights on.
Why are the red lights on the sign right down there on what appears to be the horizon?
Yeah, but hang on. Bear in mind,
all black below the red lights.
Bear in mind that the effects of refraction are negligible, right? That doesn't mean that you can. It's supposed to be up here somewhere, isn't it?
Quit trying to do that.
Right, where's the line meant to be? I don't know exactly where it's meant to be, but the line that we're not meant to see below is meant to be up here somewhere. It might be there, it could be there, it might be somewhere.
The horizon, okay. It has to be on flat Earth,
If the effects of refraction are negligible by Mick West's own authority, how is it that we're seeing so much variation? Because that's not negligible. That's a lot.
How is so much blocked in the videos that I showed you? Obviously, refraction is going on here to make these things available.
Darwin's dealt with that, and I agree with Darwin. It is the waves in the foreground blocking it out.
No, oh my God! Back the waves.
It's called perspective. That is perspective.
This is embarrassing.
So water doesn't find its levels, so you can't really trust any water because it's just waves going.
No, the waves that are below your eyes are blocking hundreds of feet in the distance.
let's go with the line of foot that we shouldn't be able to see is somewhere along here. The effects of refraction, by their own admission, is negligible. How are you arguing for all of this distortion or all of this like visibility when it's supposed to be negligible?
It's not that.
Yeah, but Riley, I've obviously completely missed your point, because if you're trying to argue it's negligible, then you think it isn't negligible, right?
No. I'm not trying to argue that it's negligible. I'm just citing your own science that says it's negligible.
Oh right, yeah, because that's the whole point. Is that, like, you know, you're calling for a lot of refraction or whatever.
No, you guys are calling for a lot of refraction. No, you guys are calling
to
for
create this thing. No, you are.
No, I'm not. I'm limiting it to negligible.
So why are you showing me pictures on a bridge with all this miraging going on? If
because
that's
that was in the
point you're trying to make.
That was another example. Doesn't have to do anything directly with what we're talking about now.
I'm trying to minimize the application of refraction because it's supposed to be negligible. You guys are trying to expand it.
I think you're taking the reference to that paper out of context.
Yes.
Well, go and look at the paper then and tell me.
If Riley's taking it, you can bet he's taking it out of context. Yeah. And don't worry about making bets with Riley, because if you're wrong, you don't have to pay up. It's okay.
Riley, I'm just saying what so you disagree. You think it's you think you disagree with this paper. Is that what you're saying?
I'm saying we should apply what the paper says.
Right, okay, because that's what I'm saying, is that how is all this obstruction happening on the waves if it's not some atmospheric lensing, as you like to say, or whatever? What is creating that drop?
Because we're not talking about the waves and all that you just
recited. Sorry, I forgot. You are genuinely a wave earther now. You're just all about waves.
I was actually talking about those waves, and I still am opinionated that whoever is filming on the coast, not filmed from a boat,
no, I'll let you go.
Under the maximum height of the waves that are seen over the lake.
Yeah, dude. But whoever was standing on that picture earlier is clearly standing above the waves.
No,
right?
you are assuming this, but you're basing this assumption on absolutely nothing.
Dude, if the wave was as high as they are, it would have struck nearly all.
Yeah, but you don't know how high he was standing.
And
you just don't know.
On a hill, dude. He was on a hill. He's in like a field or something. I'm talking about.
No, but you don't know. You don't see it. You don't get to see where he's actually standing. So you're making all these assumptions.
You're making the assumption about what I'm talking about. He's on a field.
He said it himself. He said it himself. The information is in the video somewhere.
I don't get to see it.
Then look for it. It's there.
Yeah, sure. You can say it's there. You can
you're
assume
saying
it's there, but you don't get to see it
waves.
from that actual picture.
You're saying, right? No, listen, Arwen. You're saying that there's people standing on a hill, because they're clearly zoomed out and they're on a hill well above sea level, right? How high, I don't know, but above sea level. So they're seeing obstruction.
I didn't see that in that last video. Really.
So they're being, well, we've seen videos like this, and Riley had one earlier,
but this is not the one.
And yes, well, it's the same question. So that they're seeing obstruction from there, right? And they're seeing obstruction. So that's a wave. So if you're standing on the beach at that point, the wave would be freaking massive and you'd see nothing. If they're seeing a wave from up there, doesn't make any sense.
Yeah, but
it does make sense, because even if you go high up, eventually the waves that will be also in the far distance will also start to give slight.
No, you're missing my point.
I'm not missing your point. I'm explaining the dilemma.
No, if you're standing on a hill and you're seeing obstruction due to waves, right?
Yes.
Then and it's that great that you're seeing it. That same person standing down at the bottom of the hill on the seashore should see nothing, because there should be a big wave there.
Yeah, but you're conflating the two videos.
Yeah, that's true.
I'm giving you.
If the waves would be that high that you would still see them further in the distance when standing up a hill, then yes, can I please finish my freaking sentence?
No, you can't. You keep saying
shut the hell up then. Goodbye.
Well, because your waves doesn't work. Don't get upset.
Cat, did you make Arwen cry?
Yeah, I think I made another one cry.
Oh, Cat.
It's not cool, Cat.
Well,
I'm sorry, man, but this waves thing is absolutely silly. It's absolutely ridiculous.
You said it yourself. If you get low enough, the whole wave will block out the whole thing you're looking at.
No, because you're saying there has to be a consistent wave. There's just one consistent wave that's not moving. Right, so if there's a wave big enough that when you're on the hill you're seeing obstruction, what do you think how big that wave has got to be when you're on a hill and it's obstructed?
Where is the evidence that I've cited today that's on a hill?
Where the angles, man? Come on.
You showed a video.
How can what Cat's saying not make sense to you guys?
It makes sense, but he's conflating the two videos that I said. He's trying to imply that the guy that saw it during the day was
I'm
on,
trying to
was
understand
on
how
a
a
hill
wave.
but had massive waves. That's not the case.
I'm trying to understand how big waves, can give you this obstruction. And I'm asking, you've shown a video earlier. It's one of the first ones you showed of a guy.
We have maybe 4 or 5 minutes tops left on this broadcast, so I'll do a couple of links and say if you're new to the channel, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to join future shows, there will be a link in the info box below that, and indeed this show if you wanted to get in and do a last minute bit of trolling. The rules still apply, there is no swearing. If you do swear, you will still be kicked, but of course welcome back on the next show. So yeah, a couple of minutes left to do that. I'll let the guys in the audience know one more time, in the panel know one more time that we've got a few minutes left, and then I'll come back just one last time to thank you guys for watching.
In the interest of honesty here, look, dude, in order for you to be down near the water and for a wave to obstruct way hundreds of feet above your eye level on a flat Earth, how high does that wave have to be?
Probably a foot, maybe a foot and a half. Not a lot.
A foot, foot and a half above?
Yeah, it depends on how close to the wave you get.
How close do you think they are?
Is a foot and a half.
Why don't you show a
the wave you
mathematical
get,
demonstration to confirm what you are saying? Why don't you? Where's the example? How high is the wave above your eye level, considering a flat plane? How high would that wave have to be? How far away in order to block, say, 600 feet?
Well,
you've got about 60 seconds left to get your answer in.
Feet.
Look at it this way.
About
if we
60
compare
seconds
this
left.
video to the Jenna Frodo one where she was chopping off half the buildings, notice how there's not a lot of waves here. So there's not going to be a lot chopped off there, and that's consistent with what we see.
But there is something chopped off. So why is it chopped off?
There's no, because it's convergence. This is what I was trying to say to you before. The bit that's dropped off.
Convergence doesn't chop things off.
Yes,
Riley.
Unless there's atmospheric condition.
You can even
Riley, check this. Check this, Riley. This is Jenna Fredo. She's 15 feet above the lake. Okay? You see her zooming in on Toronto here?
Yeah, I can see it.
She said Toronto zoom 2, 31.45 miles away. Let me enlarge my screen.
Hi, Huey. Good to have you.
Okay. Hello, Huey.
Hey, Nathan. Hello, Curve.
Now, Riley, she's 15 feet above the lake. Invoke waves. Invoke waves for all of the obstruction over here to this side of the tower. Where's the Rogers Center?
Just
Remember,
let me compare.
The top of it's like 300 feet above the lake. She is 15 feet above the lake, she says.
Let me have a minute. Let me have a minute to consider what you're showing. So can you just leave it on, Nathan? Just present to everyone so it stays on the screen so I can see it and compare it to the other one that Jenna took.
My avatar, Riley. Click on my avatar.
You got 30 seconds, Anthony. 30 seconds.
Is 30 seconds is all we got left?
Yep.
Uh-oh. Think fast.
Oh, right.
Think
Okay.
fast.
I just
fast, Riley. Waves.
Come on, don't troll it.
I find it extremely amusing that Jenna Fredo, a flat earther, would lie on her belly to obstruct the view when she's trying to show the opposite. That's hilarious. Riley, you're a pillock.
Did he say she laid down?
But she'd have to. It's a lake.
Yeah.
I mean, how high do the waves on a lake get?
Yeah, they're not that big.
This wave thing is absurd.
But
Right, I've got an answer for you.
Above.
It's
She's
desperation.
15 feet above the lake here.
We've only got 30 seconds. How long have we got now? This is going to go on. Well,
we've
not enough time to answer it, so we'll have to carry on.
Cheers for tuning in. We'll own Riley again tomorrow, or maybe a couple of hours.
Riley wrecked again.
Yeah, of course.
Riley wrecked again.
I can give you 30 seconds.
Can you just wait till I show you Brenda wrecking?
Whoa. Guys, if you want 30 seconds, Anthony, you can have it.
You wait till you see Brenda wrecking.
I'm not going to be heard, clearly.
It was a good effort, Anthony.
Talk about desperate.
If you want 30 seconds, you can have it.
We need to get Pete on one of these calls, man. That guy's hilarious.
No, we don't.
You're just going to be trolled.
Yeah,
Sorry.
we do, man.
You need to join earlier, Anthony.
When Pete comes on, we don't talk about the shape of the earth.
Yeah, we just talk about dodos.
We talk about dodos and
resurrection,
trannies and stuff. Oh,
somebody in the chat was talking about dodos.
And with that, I am going to say a huge, massive, enormous thank you to all of the live audience for joining us, and thank you very much for sharing the show. I do actually appreciate it hugely. So also a massive thank you to all of the panel for making this debate possible. Be sure to like, share, comment and subscribe. I've been Nathan Oakley, and I will see you all in the next video.